Imagine a world without a sun, a planet drifting alone through the cold, dark abyss of interstellar space. These cosmic nomads, unbound to any star, are known as rogue planets. For a long time, they were just a fascinating idea, a theoretical possibility. But now, thanks to incredible advancements in astronomy, we're finding more and more evidence that these lonely worlds are not only real but could be incredibly common. So, where do these planetary outcasts come from? How does a planet end up wandering the galaxy on its own? Well, astronomers have a couple of leading theories. The first one is a story of cosmic violence and eviction. Picture the early days of a new solar system, a chaotic and crowded place. Young planets are just forming, jostling for position around their newborn star. It's like a game of cosmic billiards, with immense gravitational forces at play. In this celestial shuffle, a smaller planet might get too close to a massive gas giant. Like our own Jupiter, the giant's powerful gravity can act like a slingshot, flinging the smaller world out of the system entirely, sending it on a one-way journey into the interstellar void. It becomes a permanent exile, a rogue. This ejection theory is compelling because we see evidence of this kind of gravitational chaos in many young star systems. It's a dynamic, unstable dance, and not every planet makes it to the final, stable configuration. Think about it. Our own solar system might have had more planets in its early history, worlds that were lost to the darkness long before life even began on Earth. It's a sobering thought that for every stable system like ours, there could be countless lost siblings wandering the cosmos. But there's another, equally fascinating possibility. What if some rogue planets were never part of a solar system to begin with? What if they were born alone in the dark? This is the direct formation theory. Imagine a massive cloud of interstellar gas and dust, similar to the nebulae that give birth to stars. Usually, gravity pulls the densest part of the cloud together to form a central star, with the leftover material forming a disk that eventually creates planets. But what if a region of this cloud is just dense enough to collapse and form a planet-sized object, but not massive enough to ignite into a star? This would create a sub-brown dwarf or a free-floating planetary mass object, a world that formed in isolation, destined to drift through the galaxy from the moment of its birth. This process challenges our traditional ideas of planet formation, suggesting there might be more than one way to build a world. The truly mind-boggling part is just how many of these rogue planets might be out there. Detecting them is incredibly difficult. They don't shine with their own light, and they're not orbiting a star that would illuminate them. So how do we find them? One of the most powerful techniques is called gravitational microscopy. It's based on Einstein's theory of general relativity, which tells us that massive objects bend space. When a rogue planet passes directly in front of a distant star from our point of view, its gravity acts like a lens, briefly magnifying the star's light. This characteristic flash, this temporary brightening, is a telltale sign of an unseen object passing by. By studying these microlensing events, astronomers can estimate the mass and number of these invisible wanderers, and the initial results are staggering. Some studies suggest that rogue planets could outnumber stars in our Milky Way galaxy. Let that sink in. For every star you see in the night sky, there could be dozens, maybe even hundreds, of dark, cold worlds drifting silently in the spaces between. If these estimates are even close to accurate, it means the galaxy is teeming with these unbound planets, making them one of the most common types of objects in the universe. This cosmic abundance would fundamentally change our understanding of how planets form and how matter is distributed throughout the galaxy. We've been focusing on the bright lights, the stars, but it might be the dark, unseen worlds that hold the majority. This leads to the ultimate question. Could life exist on a rogue planet? At first, the idea seems impossible. Without a star, the surface of a rogue planet would be frozen solid, a world of absolute darkness and unimaginable cold. Any atmosphere would freeze and fall like snow, leaving a barren, airless wasteland. It's not exactly a welcoming environment, but the story might not end at the surface. The key could lie deep beneath the ice. Many planets, including Earth, have hot, molten cores that generate internal heat through the decay of radioactive elements. A sufficiently large rogue planet could have enough internal heat to maintain a liquid ocean beneath its thick, frozen shell. This ice crust would act as a perfect insulator, protecting the liquid water below from the freezing temperatures of deep space. So you could have a global subsurface ocean, a hidden world of liquid water warmed not by a sun, but from the planet's own core. We see a similar phenomenon in our own solar system with moons like Jupiter S, Europa and Saturn S, which are thought to have subsurface oceans heated by tidal forces. A rogue planet could achieve this with its own geothermal energy. In this dark, hidden ocean, life could potentially arise. It wouldn't be powered by photosynthesis. Of course, there's no sunlight. Instead, it would have to rely on chemosynthesis. This is a process where organisms derive energy from chemical reactions, not from light. On Earth, we see entire ecosystems thriving in total darkness around hydrothermal vents on the ocean floor. These vents spew out heat and mineral-rich chemicals from the planet's interior, providing all the energy needed for a complex food web of bacteria, tube worms, and crabs. A similar ecosystem could exist on a rogue planet, huddled around geothermal vents in its subsurface ocean. Life there would be truly alien, adapted to eternal darkness, immense pressure, and a chemical-based existence. It would be a biosphere, completely independent of a star. Exploring such a world would be the ultimate challenge. We would need to land on a perpetually dark, frozen surface, and then drill through miles of solid ice to reach the hidden ocean below. But the reward would be monumental. The chance to discover a completely separate genesis of life, an ecosystem that has evolved in conditions utterly different from our own. Rogue planets represent a new frontier in our search for understanding the universe and our place in it. They are the galaxy's hidden population, silent witnesses to cosmic history. They challenge our definitions of what a planet is and where life can exist. They remind us that the universe is far stranger, more complex, and more full of possibilities than we can ever imagine. The next time you look up at the night sky, remember that the darkness between the stars might not be empty. It could be filled with countless unseen worlds, each with its own story, waiting to be discovered. Thanks for joining me on this journey into the dark. If you enjoyed this exploration of cosmic nomads, be sure to like, subscribe, and hit the notification bell so you won't miss our next deep dive into the mysteries of the universe. See you next time.